Okay, so this is day 2, exponential decay. And what we're going to do is on the left, we're going to put growth notes. And on the right, we're going to put decay notes. And then in the middle, we'll put what they have in common so that you know what carries over from what we learned yesterday. So yesterday, we learned growth. And the equation was y equals a times 1 plus r to the power of t. And we're just going to sketch this. So with growth, you have an asymptote at y equals 0. And the curve gets infinitely close to the asymptote and then shoots upward. Okay, the equation for decay is y equals a times 1 minus r to the t. And for decay, your asymptote is still y equals 0, but it's going to come down and get infinitely close to the asymptote. So a decay curve is falling, a growth curve is rising, going up. Another form, a simple growth curve, is f of x equals a times b to the power of x. That's still a growth curve. It's just a different notation. When it's in that form, b has to be greater than 1. It cannot be a fraction. So for it to be growth, your b value could be something like 1.13. That's bigger than 1. It could be a fraction like 4/3, and 4/3 is about 1.3. So as long as the b value is greater than 1, it's actually growth. Now, for the decay curve, your secondary formula is the same. F of x equals a times b to the x. The difference is, though, that b has to be less than 1, but greater than 0. In other words, it has to be less than 1, and it can't be negative. It has to be a positive. And just like growth, it can be a fraction or a decimal. So an example would be 1/3. That's a fraction that's less than 1. That's positive. Or a decimal like 0.68. That's less than 1, but it's still positive, and that would be decay. Okay, so what is the same? What is the same is what the basic letters in growth and decay. Sometimes, by the way, this is referred to as population growth. This is population decay, whereas this is just considered growth, and that's decay. So these two specifically refer to a population. All right, so what's the same? The a value is still the initial amount, which is when t equals 0. So that's going to be true for both of them. T is still time, which oftentimes is represented with an x. The lowercase r is the growth rate when it's in a decimal form, and it's the percentage of growth or growth percentage when it's in a percent form. So you have to base the form of your answer off of how they phrase the question. If they say they want the growth rate, give the decimal. If they say they want the percentage growth, give the percent. And then, of course, the y value, or the f of x value, is the amount at time t. So in order to get the amount, you have to know at what time you're talking about. You have to enter a time. Okay, so first thing we're going to do is do a quick practice on, is this growth, decay, or neither? Okay, so looking at number 1, the x is not in the power, is it? It's not. So this one would be neither. In order to be exponential, the x has to be in the power position. This is actually y equals mx plus b, which is a line equation. Okay, number 2, you have a base 2 to the power of x. Because the base is greater than 1, it is growth. Okay, number 3. Number 3, 3 is the initial value, but that's not what we're being asked. We're being asked, is it growth or decay? The b value is 1/2. which is less than 1. So this would be decay. So make sure you're looking at the b value or the base of the exponent to figure out which one it is. Number 4, this has a negative in front of it. Neither one of these have a negative in the front. So this is neither. Okay, number 5. On this one, the x again is not in the power position. So it's neither, because for an exponential, x has to be in the power. This is actually a cubic, and it looks kind of like an S shape going up or down. Okay, number 6. Our initial value is 4, and then the base b is 1.3. This is bigger than 1, so this would be growth. The 1.3 is bigger than 1, so it's growth. Okay, number 7, the initial value is 2. The base is 0.72. 0.72 is less than 1, so this is decay. And the last one, the initial value is 1/3. The base is 4. 4 is bigger than 1, so this would be growth. Any questions about labeling growth, decay, or neither? Okay, flip your page over. All right, we're going to do some graphing. And this is just like how we did graphing yesterday, except that we're going to graph decay curves instead of growth. So example 1, we're going to graph g of x equals 3 times 1/2 to the power of x plus 2. Okay, so for this one, your base graph is y equals 3 times 1/2 to the power of x. That's your base. The base includes the initial value. So what we're going to do is get 3 points from the base graph. So draw your extended H chart. And the values we pick are the same. So we're going to do 0, 1, and -1, which is pretty much the same you're going to do for all of these. All right, so let's do 0. So I have 3 times 1/2 to the 0. Do the exponent first. Anything to the 0 power is 1. So 3 times 1, and then you always multiply second. 3 times 1 is 3. Okay, let's do the 1. So I have 3 times 1/2 to the 1. Do the exponent first. 1/2 to the 1 is 1/2. So now I have 3 over 1 times 1/2. And remember, when you multiply straight across, 3 times 1 is 3. 1 times 2 is 2. So 3/2. And now the -1. 3 times 1/2 to the -1. The -1 power flips the 1/2. It makes it 2 over 1. And then the 1 is positive, so it goes away. 3 times 2 is 6. All right, let's go ahead and plot these on our graph. So 0, 1, 2, 3. And this is the base, so you don't have to label these. 1, 1.5. -1, 1, 2, 3, 4, 5, 6. And we're going to draw the asymptote, which is just like yesterday. Your basic asymptote is at y equals 0. So my base graph comes down and gets really flat looking on the right. The left of it shoots up without ever going completely straight. So that's your base graph with the asymptote y equals 0. Now we're going to use those transformation properties. I'm not going to rewrite all the properties. You have them on your notes if you forget. But we have an x plus a 2. So when a number is being added to the x, it's always a horizontal translation. And for the x, it's backwards. So if it's x plus 2, it's a -2 to the left. All right, so take each of your 3 points, count 2 to the left. 1, 2, 1, 2, 1, 2. I'm going to draw my curve. Translating left or right does not change the asymptote, so we're good where we're at. But we do need to label our points. You can label your points by counting. This is 1, 2, 3 to the left, so negative 3, 6. This is 2 to the left, so negative 2, 3. This is 1 to the left, so negative 1 up 3 halves. And that is your graph. All right, we're going to do one more graph, and then we're going to get some working time. So let's do another example. We're going to do f of x equals 2 times 1/3 to the x minus 3. Okay, so our base graph is y equals 2 times 1/3 to the x. So we're going to calculate points for the base graph. And you always use 0, 1, -1 to keep your values small. So let's take the 0 and substitute it into the base graph. So that would be 2 times 1/3 to the 0. Do the 0 first. Anything to the 0 is 1. So this is 2 times 1, which is 2. Now we do the 1. 2 times 1/3 to the power of 1. Anything to the power of 1 is itself. So I have 2 over 1 times 1/3. Multiply straight across. 2 times 1 is 2. On the bottom, 1 times 3 is 3. Okay, and the last one, -1. So I have 2 times 1/3 to the -1. The 2 stays the same. The negative exponent flips the fraction, so it's now 3 over 1. And then we multiply straight across, we get 6. All right, go ahead and plot those 3 points on your graph paper. 2. Bless you. Okay, so let's describe the transformation from the base graph to our graph. The only difference is there's a -3. It's on the outside of the exponent. So when you add or subtract to the outside of the exponent, it is a vertical translation, so vertical. And for vertical, what you see is what you get. So it's -3 down. So that's the description. So take each of your points off your graph and count down 3. 1, 2, 3, 1, 2, 3, 3. Now, a vertical translation up or down does move the asymptote. The asymptote shifts up and down with the curve. So you're going to want to count 3 down for your asymptote. 1, 2, 3, and draw your new asymptote, which is at y equals -3, because we went from 0 down. And then you can draw your curve. Remember that your exponential curves, when you shift down, they start to look almost identical on the high side, and then they split apart on the low side. Now, to figure out your points, just count spaces. This one's 1 to the left, so -1, and it's up 1, 2, 3. So -1, 3. This one's down 1, so -1, and it's 0 to, oh, sorry, it's 0 right or left, so 0, -1. There we go. And then this one's always the tricky one because we're 1, 2, and 1/3. We're 2 and 1/3 down. So, but we can't use that on the graph. We need to do improper on the graph. So we got to switch it to a mixed number. And the non-formula way to do it is to add 2 plus a third, which means you multiply the 2 by 3 over 3, which gives you 6 plus 1, 7/3. So this point is negative 7/3, comma 1. Now, if you know the shortcut and you can remember it, use the shortcut. But if you can't remember the shortcut, just remember add the big number to the fraction and you've got it. That's, by the way, what the shortcut does. It adds the big number to the fraction. It's just a shortcut. Okay, that is the end of the notes. Are there any questions?